So we've got another question here, but this time we're not actually using a continuous set of data. We're looking at a discrete set of data. We kind of know that just by looking at the graph and seeing all of these discrete points kind of listed all about, kind of like jumbled up there. We have a listing of all of them. There's nothing wrong with making this a relation. We do see that the mass in kilograms is on our independent axis and the height in meters is on our dependent axis. We see the scale is appropriately adjusted for us, and each one of these represents apparently a polar bear here on it. So how do we read this? Well, which bear has the greatest mass? So if we're looking at greatest mass, I think I could do that a little bit better. Greatest mass, which one of these should we be looking at? Well, obviously mass goes with this. And if we're looking at the greatest mass, then we should be looking at the point that has the highest value of this independent axis. So what I'm going to do here is I'm just going to start listing out a little bit of the ordered pairs from A, B, C, D, E, F, G, H, I. So this is going to kind of help us out just figuring out what's going on from our graph and able to kind of pull up values when we need it. So let's kind of list out our ordered pairs. And again, we're going to kind of start from lowest and go to our highest. But in this case, we're going to kind of list them out in terms of our domain or our independent axis here. So let's go ahead and let's say our A value, it looks like it's just above 100. Let's say that's about 125. And these can be approximate values. And our height looks like it's going to be a little bit below that, so 0.75. That would be our first ordered pair. Second, we have B here. We got 200. That's right on the line of 200. And I'm going to say that this is about 1.25. Keep it on going. I have my next coordinate. Looks like it's at C, right at 300. And it looks like we're at, I'd say that's about 1.75. And now we get to D and E. Now in this case, they both have a mass of 400. I'm going to use my D coordinate first. So D, and I'm at, let's say we're at 2.25. I got to continue on over here. And we're still at 400. And it looks like E is just after 2.5. Maybe we can say that this is going to be at 2.6 perhaps. Again, rough approximations, but that's okay. H, we're at 550, sorry. And it looks like we're at 2.25. Keep it going. We got G, at 600 and 3. And then finally, I think I can sneak it in here. We got 625. And I'm going to approximate that to be 3.4. Okay, end off my brace. So why did I do this? First off, I wanted to do this because I wanted to relate set 1 to set 2. So, of course, we have masses as my first set, and I have the height as my second set, as we normally would if this was given as a table or anything like that. We always like to do masses to height. Mass is our first set, heights are second, and the relation between them is just the height and mass of the polar bears. So which one has the greatest mass? Now that we can have this, and we could have read this from the graph, but we can read this from here as well, we can see that this last polar bear right here, this one has the greatest mass, and this is polar bear F. The mass of polar bear F equals, and again, this is just approximately 625 kilograms. And that was kind of like A. For B here, we can take a look at which bear is the shortest and what is that height. So now we're looking at our range values and we're looking for the lowest range value. And that should be our A coordinate over here. So we have polar bear A, and that height, we can recall it from our ordered pairs, 0.75, and that's meters. Which two bears have the same mass? So again, we're looking for somebody that has the same domain value. And it looks like these two bears, bear D and bear E, have the same. D and E, and their masses are equal to 400. A little bit of a side note here. Would this be considered a function? And we should be able to figure out that since they have the same domain value of 400, but two different range values, so this 400 here and this 400 here, this would not be considered a function. No, the question doesn't ask that, but that's okay. And lastly, we have which two bears have the same height. So looking at our list, we're looking for two bears that share the same height. Let's see if we have one. I have this one here. Let's do it with a different color. I have this guy here and this guy here. So D, and it looks like it was H. And I'm looking at the same range value here. So for this, we got D. Ooh, let's do that in green. We got D and H have the same range value, and that height is equal to 2.25 meters. I'm going to add one extra little question onto this one, and I'm just going to kind of say, okay, give us the domain and range. So E, what is the domain and range? Okay. So if we're looking at domain and we have all of our ordered pairs, our domain would just be our discrete set of data, and it's just going to be our first numbers as we see it. So I'm going to kind of do E over here, and I'm just going to label it as my domain. And we would, again, use a brace here, and we would go from lowest or smallest to biggest. So 125, 200, 300. I would only put 400 once, 550, 600, and 625. Ooh, let's make that a 25. There we go. So here's my domain. It's all the list of my first elements in increasing order, and I'm not doubling up a value. I'm not doubling my 400. Range, same thing. Except this time I'm reading from lowest to highest. So I want to go ahead and start listing off what my lowest range is, 0.75, then my next, 1.25, and then keep on going from that. 1.75, 2.25, 2.6, I approximated. I wouldn't put 2.25 again because we already have it. 3, and then 3.4. Again, with commas all around it and with braces. And that would be our domain and range, just as a little bit of an extension for this one.